So we're going to turn this week's attention to web services, which are essentially a form of communication using everything we learned about the internet and the communications and web pages and stuff like that to be able to simplify the path by which we share data across two computer systems. So to this point, we've written main methods, we've written GUIs, we've written some business logic, web logic, we even built some EJBs, whether we realized it or not. But we haven't got a simple way to share data between two computers. There's lots of possible ways, don't get me wrong. We built sockets, we sent stuff back and forth. But a lot of that has a lot of maintenance, a lot of overhead, there's a lot of confusion, particularly if I want to share it between two different computing systems that aren't the same language, that, like between very different varieties of applications that could be built. And so we've been doing it for decades, don't get me wrong, it's not something that's brand new, but we started with this ones and zeros serial port type communication where we literally take one computer and plug it in via printer ports or something like that to another computer, and we would send ones and zeros back and forth, and you have to interpret it as such. That grew into something called CORBA, the Common Object Request Broker Architecture, which allowed us to define objects at a higher level and be able to share data back and forth instead of its ones and zeros. The alternative is we've used flat files, both in internet communication and also offline, FTPing files back and forth. So we've been able to share data that way. And then we've also had XML as a format inside of there that we can now use to be able to share data at a much higher level. Now, each of these has a portability question with them. The binary stuff is very small data. It's very easy to transport. I can send you 30 booleans for the cost of less than one character because I can represent 30 bits as ones and zeros, where one character is normally 32 bits in a standard format these days. But that makes it really tough to figure out how to debug that code, what's in there. So text is much easier to debug, and XML is not only easy to debug, it's easier to generalize and grow upon. And so we have kind of moved from where we used to have to be hyper efficient in our data to now where we can be a little bit less efficient because we can move data a lot faster. But then we don't have to worry about that, but we want to basically make it easier to work with and easier to understand. So either one of these, though, has no protocol associated with that. We can talk ones and zeros or we can talk text. It doesn't get to the point of what does our request and our response look like. And so enter SOAP, the Simple Object Access Protocol. This is actually designed, I think, by Microsoft as a way of being able to share data in XML as a standard request response format. It defines what a request looks like, it defines what a response looks like, and how to be able to share those as text messages back and forth, and then we can customize what's inside of the message from there. And then I will come forward, and you can come forward, and then you can see exactly how I define messages. So because I know the wrapper, I know what the envelope looks like. And the way I can define then messages in web services is something called WSDL, the Web Service Design Language. So it takes SOAP, and instead of saying, oh, there's some request, some response, there's an envelope that sends it back and forth, but what is the request look like? The Web Service Design Language, WSDL, defines explicitly what are your services. A service is a bunch of stuff. A service is kind of like an interface in Java. There's a bunch of things you can call, but they all get wrapped up into an interface. And then inside of the service is a bunch of operations, which is the same as a method. And so I can basically kind of define exactly what you're going to get, what you're going to look like, through the combination of WSDL, defining what you're going to get, and SOAP, how you're going to ask for those requests. So here's an example of what a WSDL looks like. Can you read that? I mean, I would say maybe pause it and give it a once over here. I'll point out a few highlights inside of here. There's messages inside here. So you have a get message. You have a response to the get message. You have a post message, a response to the post message. A message is basically any text that's being sent or received. But WSDLs aren't necessarily meant to be super readable. They are readable if you're designing them. You can design them by hand. Generally speaking, I can design them at a higher level and let them be generated. I only want to design them super meticulously if I'm dealing with kind of contractual basis. I'm just interfacing within my own system. I generate the WSDLs. But if I have some need to send data from, say, your company to PayPal, PayPal, I'm sure, designs their WSDLs with much care. They have web services out there that define them, and then they make sure they're really nicely done, better formatted than what we see here. But this is actually a generated WSDL from the tool, as you'll see that we can do it going forward. Now, there's a few other players that we want to talk about inside of here past the WSDL. There's two players that help define what the XML data looks like. The old version of that's called a DTD. And it's not really common to come into play inside of web services, but the document type definition is the old way of defining XML data structures. It defines the rules in a kind of another language of its own by what the XML structure looks like. It's not normally going to be used, so we're going to use instead something called an XSD, an XML schema definition. Its job is to define in an XML format exactly what's allowed in a message. So you can define a person object, you can define a product object, you can define a customer object, you can define whatever you want to, and what are the attributes, what are the data items that go back and forth. And so it's much more powerful, allows us to actually validate not only the structure, but also even data entries inside of some of the fields. And so it's what's used to define the XML that defines your messages. So the XSD is tied together with the WSDL typically, because the WSDL comes in an XSD-ish type formation, but I normally am going to have objects that are across more than one type of message. So again, you have a product object. I have a service that allows you to look up products in a catalog. I have a service that allows you to buy products from this system. I have a service that allows you to return things to my corporation. I don't want to have to define what a product looks like 3 times, so I define it in one place as a reusable XSD, and then the services refer to that as a common object across those. So XSDs are not required by any means, but they're often useful and helpful in defining services. The last player I want to refer to is XSLT and security. So XSLT is the Extensible Style Sheet Language Transformation. This is sometimes used behind the scenes to convert one service call into another service call. It's often used in versioning, when I have version 1 of the service, and then version 2 I add a new parameter, which is allowed to be blank, so I can make calls to version 1 and then convert that to version 2 service call and just blank the parameter. It's a way of being able to manage my system and not have to be super complex. We're not getting too much in this class, but I want you to be aware of the WS security interface, which defines standard security protocols over the top of our services. It allows us to define authentication of the caller, username, passwords, or tokens, or different ways of ensuring that the caller is allowed to make the call, and then encryption on the data in transit. So that way I know that either the whole message or at least parts of the message are properly encrypted, and so you can't steal credit card numbers by sniffing the line and things like that. And then there's also the question of message integrity. So it doesn't matter if you can't steal my credit card. If I can get you to transfer 50 cents to my account and I do that 100 times, all of a sudden I have $50. If I do it 1,000 times, all of a sudden I have $500. So how do I ensure that when you send me a request one time, you can't repeat that request over and over and over again? That's another thing that security does. So that's a little bit about web services are and the pieces that they're made up of. Again, you're not expected to design these things based off this class. I just want you to be aware there's this thing called web services, and this is what they're made up of. So you can go research it further, but we're going to leave it at there as far as what they are. We're going to look at how we call them and how we build them a little bit. So we're not going to not do anything on web services, but there's certainly much more to learn about web services beyond what we're doing here. Remember, we're just overviewing it, but hopefully you have a foundation by which you can understand where to go from here.